I don't enjoy this part of the chapter so much is because I feel like it's just, I don't know. All you're doing is putting numbers in here and it's just formulas. Find the first 6 terms of this. That just means when k is 1 through 6, find the terms. You should be able to see the pattern, or you can just do the formula every time. So if I want to find the first term, I'm going to make k1, and I would plug 1 in here. Are you okay if I just say that's 5 minus 3, which is 2?
So A equals.
No, the first term equals 2 is what we're saying. A sub 1 equals 2. And then I would say A sub 2 would equal 5 times 2 minus 3, or 7. So the first term is 2, the second term is 7, the third term would be 5 times 3 is 15, 15 minus 3 is 12. And the formula always works, right? But you also can just look at the pattern. What's happening each time? So the first term's 2, the second term's 7, the third term's 12. You're just adding 5 each time, right? So we could say 12 plus 5 is 17, or we could plug 4 in there and still get 17. Works either way. I want the first 6 terms and the 100th term, which seems a little excessive to me, but whatever. The 5th term would be 22. The 6th term would be 27. The 100th term would be 497. Huh? Not so bad, right? What about this one? Oh my gosh, it has an exponent. Same idea. If you plug 1 in there, you're just replacing k with 1, which is just negative 2. So you're just going down the list here. If I plug 2 in there, what is negative 2 squared? Positive 4. If I plug 3 in there, 3's up there. Negative 8. Be careful on your calculators, because if you type negative 2 squared without parentheses, it will give you negative 4, which is the wrong answer. What's wrong?
How do you get positive negative 2 squared? I don't understand.
Because if negative 2 times negative 2 is positive 4. Right? So the positive, an even power is always going to give you a positive answer, so an odd power is always going to give you a negative answer when it's a negative number. Because if you have an even number, a negative times negative is a positive. A to the 5th, negative 2 to the 5th is going to be negative 32. A to the 6th would be 64. Is that true? A to the 100th is like out of control.
Why would you do that? It's in like scientific notation.
It is in scientific notation. What do you get?
Negative 1.267
times 10 to the
1.267 times 10
268.
times 10 to the
30.
30th. Not negative, positive, because it's even. Yeah, that's gigantic. Notice the difference between these two sequences? This one you're adding each time, right? You could say you're adding 7. If you were describing someone what you're doing here, do you agree you're multiplying by 2 each time? Those are the 2 types of sequence we have. We call these formulas explicit formulas, meaning that you can get any value that you want. If I wanted the 1000th term, you just plug 1000 in. You don't really need the ones before it because they give you the formula. The other type of sequence is called a recursive formula, and you do need some other values. So tomorrow, we're going to write our own formula. So instead of this, tomorrow they're going to give you the pattern, and you have to write the formula. And sometimes you have to write the explicit formula, and sometimes you have to write the recursive formula, and sometimes you have to do both. So I don't know why I always start with the Fibonacci sequence, because people get confused by it, and it kind of looks a little different. But Fibonacci sequence is probably the most famous sequence, especially recursive sequence. Obviously, Fibonacci is the one responsible for the Fibonacci sequence. But here's the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. That's the Fibonacci sequence. And the Fibonacci sequence is or any recursive sequence, they have to give you at least one number. In the Fibonacci sequence, they give you two numbers. They give you two ones. And then to get every term after that, you just add the 2 before it. So 1 plus 1 gives me 2. 2 plus 1 gives me 3. 3 plus 2 gives me 5. 5 plus 3 gives me 8, right? So the difference between an explicit formula and a recursive formula, a recursive one, you have to have the numbers, like a number given to you. Usually it's just the one before it. And so this is the formula for a Fibonacci sequence. It looks really scary, but think about it. They start with A0 and A1. The next one in the sequence would be A sub 2. So if you plug 2 in for K, what's 2 minus 2? Is A0 plus what's 2 minus 1? All that's saying is to find the next term, you add the 2 before it, right? And so people get really scared by these formulas because there's lots of K's and numbers added and subtracted. Once you do a few of these, like I don't even really look at that formula. I just always say, oh, it just means add the 2 before it, and I don't freak out about what K is every time. A lot of times they only give you one number, and so that's why I said I probably should not show you Fibonacci sequence first, but I feel like it's a random math thing I could show you. It might be on Jeopardy someday. But here we go. Here's kind of more like what you're going to see on your homework. It says write the first 4 terms and the 8th term of the recursively defined sequence. And for a recursive sequence, they're going to give you a term, they're going to give you a formula, and they're going to tell you where to start with K. Different than Fibonacci. Fibonacci started with A sub 0. This one starts at A sub 1. If they want us to write the first 4 terms, do you agree they already gave us the first term? We only had to find 3 of them, because the first term is just 15. But to find the second term, right, this is where you have to get past the feeling like this is the crazy formula. If I want to find the second term, do you agree if I plug 1 in for K, that would give me the second term, 1 plus 1? And if I plug 1 in for K, all that's saying is A1 plus 3. Or it's just saying you take the 1 that they gave you and you add 3 to it, which would be 18. If I want to find the next term, it means I'm going to take the one before it, which is A2, and I'm going to add 3 to it. And what is 18 plus 3? 21. And if I want to find the next term, I'm going to take 21, the one before it, and I'm going to add 3, and I'm going to get 24. Notice on this one they didn't ask us to write the 100th term. Because to write the 100th term would be kind of a good amount of work, right? But you can't just plug 100 in. Just add 3 a bunch of times, right? It is true. They asked us for the 8th term. So you have 2 ways to do this. One way is you could just find the 5th, 6th, 7th, and then the 8th term. Or you could think about the 8th term, you're going to start with 24, and we're going to add 3 how many times until we get to the 8th term? 5th time, 6th, 7th, 8th. We have to add 3 4 times, or we're just adding 12 to that. Does that make sense of where I'm getting that? So 24 plus 12, I could tell you that the 8th term was 36 without having to do all the steps in between. I don't know why I dislike this stuff so much. Give me a graph. Give me a quadratic. Give me some logarithms. Alright. I'm super excited for the end of this chapter when we get to do proof by induction. I'm so excited to do that.
How many left?
752.
We're doing proofs. All you have to do is
So we're gonna do a test before the final.
we're always gonna blow some less.
Stress at the end.
It's a serious topic.
We're probably gonna have a test like next Thursday. Maybe Friday. If they do finals Wednesday. But you gotta keep it
Okay.
Yes.
in the morning.
As long as you guys drink a lot of water.
I don't know why it's been an hour, but we kind of freaked out on this one. I don't know, it looks the same to me, but they give you the first term again. So the first term is 2. So to find the second term, notice they tell you start when K is greater than or equal to 1. And notice, if I plug 1 in for K, 2? And that just means take 3 times the one before it. Or that's just 3 times 2, which is 6. And honestly, when I look at these formulas, maybe I don't do it the right way, but I don't even look at the case. Like, I just always know that means, oh, just do the one, like, 3 times the one before it. Or 5 plus the one before it, or whatever the problem is.
What if it's like k plus 2?
Well, then, like the Fibonacci sequence, you might need the 2 before it. However many numbers they give you, that's what you'll be using before it. So Fibonacci, they have to give you the 2 numbers, because those both go into the formula. Most of these are just one number.
What if it only gave you one number and then gave you plus 2? So then would you just have to skip that number?
They couldn't. They wouldn't.
Would B3 equal 18?
B3 would equal 3 times the one before it, which is 6, which is 18. B4 would equal 3 times the one before it, which is 18, which is 54. They also ask you for the 8th term. Notice this time we're multiplying, we're not adding. But again, how many times would I have to multiply by 3 to get from the 4th term to the 8th term? 4. So I'm going to take 54 times 3 4 times, or 54 times 12, which is, because I'm multiplying by 3 each time, right? Right, no, it's times, you're timesing 3 each time. Or you could just take 54 times 3, and then times 3 again, and then times 3 again, and then times 3 again, which is the same as 54 times 3 times 4, which is 468. Is that true? What's the answer to this? Dang it. I'm trying to randomly remember the answer. Not even close. Questions about that? The only other thing on your homework today is talking about what happens as you plug in bigger and bigger values into a sequence. Is it going to go towards a number, or is it going to go towards infinity or negative infinity? And we're going to talk more about this in 9.5 when we talk about adding up a sequence. I'm going to teach you how to add up an infinite sequence, which is pretty exciting that you can add to infinity and get a number out of it. So that's super cool. Not impossible. We want to talk about the in behavior of these sequences. What's happening as n is growing? So we can say if a sequence converges. Yes.
I have a question. I did 4 times 3 and then 4 parentheses and it's 6.
Oh my gosh, Brandon, what are you doing?
So you
That's
have
what
to
I
do
got.
54 times 3
I thought it was like,
power. Completed 4th power.
which is not right. This is right.
Which is 437.
Right.
Why is that not right?
But if it was multiplied by 3 times, each time would be 54 times 3 times 3 times 3
Oh
times 3.
my goodness, hold on. You guys are hurting my
So
brain.
it is 4374, but it's you multiply it by 3 to the 4th
It's
power.
54 times 3 4 times. Yeah, you're right. Brandon's right. I was wrong in writing my formula. Brandon has the right answer.
What? Boom! Someone needs to figure out what they're doing. It's on the back push.
I'm going to talk to Oliviero.
With the 3 zeros and 2.
No, because we were adding in that one. Pretty sure I did this wrong in the second hour. Just saying in case you want to tell them.
Throw that on the no, let's not tell them. It'll be all good.
Okay, so let's talk about why I wrote that wrong. Because I have to take this for the times 3 4 times, which is not times 12, right? Times 3 4 times would be times 3 to the 4th power. Adding 3 4 times would be like 12. But timesing by 3 4 times is 3 to the 4th. Yes.
Why isn't there a new check test up there?
I'll get on that.
You won't be up there. Wait, what? No, not today.
In this class.
I can fix it if you want.
Okay. Speaking of tests and test corrections, remember that this week, Friday is the last day to turn in test corrections and the last day to retake that test. And if you're retaking both parts of it, you need 2 class periods to do that in, right? Or come in early 2 days in a row, or stay after school a long time to do both parts. So today, tomorrow, Friday, that's it. And then retests are done for that test. So Algebra 2, Calc Lab. Alright, sorry, back to this since I did my math wrong. If a sequence converges, then as n approaches infinity, the sequence reaches a finite number. If the sequence diverges, I don't know how I should say that. Then that means as n goes to infinity, then the sequence just grows larger or smaller without bounds. This is very similar to an asymptote, very similar to the concept of a limit of what's happening. Very important when we talk about adding up a sequence of if it converges, then it does have a sum. If it diverges, it doesn't have a sum. But today you just have to do what the last examples are. Determine whether the sequence converges or diverges. If it converges, state the number. And all you're going to do is think of what happens if you pick bigger and bigger values for n, or maybe you just know on some of these. And so they write it like this, 1, 4, 9, 16, dot, 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 then they give you the formula is n squared. So think about if you picked n to be 10, what would that be in the formula? 100. If you picked n to be 100, what would that be?
Right. Big number.
10,000. Is this going towards a specific number, or is it just getting bigger? It's getting bigger, so we say it diverges. Converges means it goes towards a specific number. So all you have to do to determine this today is pick numbers. Pick 10, 100, 1,000, see what's happening.
What's an example?
Oh, let's look. If this was your formula for your nth term of your sequence, what if I picked 10 for this? If I picked 10 for this, I would get 30 minus 1, which is 29. And on the bottom, I would get 2 minus 30, which is negative 28. Which is like negative 1.0357. If I put 100 in there, I'm going to get 299 over negative 298. Which is negative 1.0033557. What if I put 1,000 in there? I would get 2,999 over negative 2,998. Which is negative 1.000333556. I think it's converging, right? Because I picked from 10 to 1,000, and it's still really, really close to what value? Negative 1. So we can say this converges to negative 1. Think about in terms of horizontal asymptotes. Do you remember the rules? We have a final exam coming up pretty soon. Horizontal asymptotes are going to be on there. Do you remember the rules and how you tell a horizontal asymptote based on the degree of the numerator and the degree of the denominator?
If it was how much bigger than small bottom and so on.
And in this case, they're the same, right? Like 3n on the top and 3n on the bottom, right? So what's the rule? If they're the same degree, how do you find your horizontal asymptote? What? It's the leading coefficients, right? And what do you notice about the leading coefficients in this? 3 and negative 3. What would you get if you took 3 divided by negative 3? Not a coincidence that happened. The horizontal asymptote for this function is the same as what it converges to. You don't have to if you know.
So it's number 7.
But what about this one, right? That only works for polynomial functions, rational functions. This is an exponential function. Do exponential functions have a horizontal asymptote? I don't know. Let's pick some numbers. What if I pick 10 here? .5 to the 10th power is 0.000976. And then I picked 100, and I don't even think I wrote the answer down on my paper, because when I took 0.5 to the 100th power, I got 7.889 times 10 to the negative 31. Because that's a negative exponent. What does that mean this number is really, really close to? Yeah, it means 31 places this way I have zeros in front of that, which means this is converging to 0. Converges to 0. And again, we just took a test over this. This is exponential decay because this is less than 1. If you graph that, it's going to look like this. So as x gets bigger, the y gets closer and closer to 0. And so you can use the idea of asymptotes to help you, but if you get stuck, just make the chart and that will help you know if it converges or diverges. Okay? That's it. Some of the work is kind of tedious tonight, but you're doing 1 through 4 all, 6 through 20 even. This is 9-4 day 1. We have 9-4 day 2 tomorrow, 9-5 day 1, 9-5 day 2, 9-6 day 1, 9-6 day 2. Where does that put us? 9-5, 9-5, 9-6, 9-6 review. I think we're having a test on the 12th. Oh dear.
Your birthday is like, no, your birthday is like June 15, 16, somewhere.
Yeah, or you could just put the test on fine.
No. And you'll probably get your day 1 review for your final on Friday after the test as well. So that way we can talk about it on Monday, day 2. Talk about it on Tuesday. Your final is Wednesday, so we'll see. I'll see if I can squish 9-5 together into one day so that we can push the test up a bit. Would be nice.